Welcome everybody to our poster presentation of our Ocean Shot proposal entitled the U.S. OceanBiocode. My name is Chris Meyer and I'm presenting on behalf of a number of co-authors and partners who all believe that this endeavor is an essential part of the UNDecade of the Ocean efforts to deliver the science we need for the ocean we want. The promise of our program is to create a comprehensive DNA sequence library for all marine species by 2030. We think this is ambitious, will transform our capacity to monitor and predict marine ecosystems, and is achievable in 10 years. Marine biodiversity is the heart of healthy ocean ecosystems and productive economies. The emergence of DNA sequence-based technologies has revolutionized and transformed our capacity to census and monitor marine biodiversity. However, while we can now pretty much sequence anything anywhere, and expect these innovations to rapidly advance over the coming decade, arguably the greatest impediment to realizing the potential of this incredible technology is our ability to provide meaning to the knowledge generated. We can create billions of DNA sequence records, but until that information is translated into species, it's just strings of G's, A's, T's, and C's with little meaning or understanding. The problem is thus dark taxa, sequences generated from analyses of mixed communities and other observing systems that cannot be assigned to a name. Here are the average proportions of unknown reads from 4 different means of sampling marine communities: eDNA, fish guts, plankton toes, and arms. 15 to 40% of the species found in these profiles cannot be assigned confidently to any assigned taxon. This exemplifies the challenge ahead and is far worse in many regions of our ocean. The dark taxa are like unregistered drivers in ecosystems. What are they? What are they doing? And how might they respond to changing ocean conditions? Over the last decade, we've made substantial progress towards our reference libraries across marine species. We have pretty good lists of species for U.S. waters, and we expect that we can deliver a sufficiently vouchered sampling of species to be able to cover all marine animal life. The promise of our proposal is substantiated by the fact that marine biodiversity is finite. Here are 2 dashboards of the current state of knowledge for U.S. marine species. On the left, we've been working in collaboration with BOEM, natural history museums, and regional partners to generate a voucher-based genomic-grade library across all marine invertebrate groups. We now have over 20% of all marine genera sampled. These lists and reporting tools help us keep track and get the word out to target missing lineages. For fishes, our NOAA partners at the Smithsonian have worked with a number of data providers and taxonomists to create a curated list of all marine species found in U.S. territorial waters. On the right, we show the regional proportion of missing species for each of the 4 most commonly used barcode markers. Overall, we're a little more than halfway, and it's a good opportunity to bring up an additional point of our project's intent. We will be going beyond the barcode in generating this voucher-based library. Using genome skimming, we are successfully recovering full mitochondrial genomes as well as nuclear ribosomal operon regions. We expect to be more regularly employing this strategy very soon, not just for fishes, but for all marine taxa. This will provide a reference library for any common locus and will enable more refined approaches to sequence-based monitoring in perpetuity. The plan we propose over the next decade to tackle this challenge is a series of regional bioblitzes coupled with standardized community censusing methods to check our progress. Working with ocean best practice groups and partners, we'll concentrate our efforts to building our reference libraries on the species of concern that are showing up in our sequence-based sampling. Here's a proof of concept example and evaluation tool for this approach. In partnership with the Western Association of Marine Labs, a BioBlitz was conducted in 2019 at the Oregon Institute of Marine Biology. Over 2 weeks, a team of 25 people collected marine invertebrates all around the region. We also had deployed ARMS, which are standardized collecting devices being used all around the world, to sample benthic diversity at 3 sites. Each dot in the plot on the left represents a marine species based on its CO1 DNA signature, and the size of the dot represents how abundant it was in the resulting community profiles. Each species is plotted against how well it could be identified before the BioBlitz based on its percent sequence identity using GenBank versus how well it could be identified using the new BioBlitz generated reference library. The dots at the top in the new known region are all gains in species identity from the BioBlitz efforts. The dots in the known knowns, upper right, were species we got in the BioBlitz but were already in reference libraries, and the dots in the old knowns were species found in the ARMS that were already in reference libraries but we didn't get in the BioBlitz. Most of these are algae or fish, which weren't targeted in the BioBlitz anyways. We intend to use the same coupled approach at partner sites across the US and beyond to generate better reference libraries and train our efforts to strategically target missing lineages. We can create coverage maps and use the method as an evaluation metric toward our goal of lifting all species above the 85% identity threshold. In the map to the right, you see our current partner sites, and we'll be looking to expand these efforts across the US and also engage internationally through ongoing UNDecade programs like Marine Life 2030. The vision and difference this OceanShot will make over the course of our 10-year program will transform ocean science forever. By bringing dark taxa to light, we'll be able to truly create a digital atlas of ocean life that reflects all marine species. Moreover, by linking sequence identities to names, we create a bridge to map natural history knowledge to community profiles, bringing centuries of taxonomic and ecological information to these omics-based censusing platforms. The OceanBiocode becomes a marine Rosetta Stone that translates sequence data to actionable knowledge of organisms and ecosystem processes. We will do all of this in a collaborative and open framework, turning out the sequence data in near real time to data aggregators such as GenBank, OBIS, and GBIF. The information infrastructure already exists for these services. This model and strategy will work and will have to work across other marine ecoregions because of how biodiversity is distributed and differentiated. For instance, we know from experience that an almost complete comprehensive reference library from French Polynesia isn't very helpful in Oregon. By linking with other OceanDecade programs, we can foster new exciting opportunities to engage local communities and marine stewards, to document their natural heritage, to contribute to a global trust of biodiversity information, and to leave a resource for every future generation to come. Marine biodiversity is one of the greatest treasures on our planet. Our OceanShot, the creation of a comprehensive OceanBiocode, will facilitate the goals of the OceanDecade to sustaining and preserving marine biodiversity, the heart of healthy oceans.